Assalamualaikum warahmatullahi wabarakatuh and hi. This is our slide presentation. Our project is about smart car parking occupancy. And this is our members.
So for the introduction, this project focuses on the development of a smart car parking occupancy system. Firstly, for the project background, the increasing number of vehicles has made parking management a major challenge in urban areas and public facilities. Conventional parking systems do not provide real-time information, which leads to congestion and time wastage. Therefore, a smart parking system is needed to improve efficiency and user convenience. Secondly, for the problem statement, users often face difficulty in finding available parking space due to the absence of real-time parking information. Many effective parking systems are inefficient and contribute to congestion, fuel wastage, and poor traffic flow. Moving on to the objectives. This project aims to develop an Arduino-based automatic parking system that can detect parking spot occupancy. The system also displays real-time parking availability to improve parking management efficiency. Lastly, for the significance of the project, this system helps users save time and reduce congestion within parking areas. It also improves facility management, efficiency, and supports environmental sustainability in line with the smart city concept. So let's move to my turn.
Our system has several main capabilities. First, it can detect vehicles entering and exiting the parking area using infrared sensors. Second, the microcontroller processes the sensor data to determine whether a parking slot is available or occupied. Third, the system updates the parking information continuously and displays it on an LCD screen. Overall, the system operates automatically and provides real-time information to users. Next is system boundary. The system boundary is limited to parking detection and information display. It only detects vehicle presence, processes parking data, and displays availability on the LCD. The system does not include advanced features such as license plate recognition, security cameras, or enforcement system. Next is system requirements and specification. In terms of system requirement, the system must accurately detect vehicles in each parking slot. The parking status must be updated in real time and clearly displayed on the LCD. The system should also operate reliably and consistently during continuous use, with stable sensor readings and system performance. For hardware requirements, our system uses several main components. Arduino Uno acts as the main controller for the system. Infrared sensors are used to detect vehicles entering and exiting. A servo motor is used to open and close the parking gate automatically. An LCD with I2C module displays the parking availability information. Other components such as jumper wires and a breadboard are used to connect and support the circuit. For software requirements, we use Arduino IDE to write, compile, and upload the program to the Arduino board. The CH341 driver is used to allow communication between the computer and the Arduino. The liquid crystal library is used to control and display information on the LCD screen.
The project is smart car parking occupancy. So about the project is we use Arduino Uno, IR sensor ada dua, and servo motor and LCD. So bila IR sense kereta lalu dan IR sensor yang pertama detect the kereta, servo motor akan bergerak, akan buka pagar, dan slot LCD akan paparkan decrease slot. So total slot ada 4. Bila kereta lalu akan tolak 1. So bila lalu IR sensor 2 tak akan detect apa-apa. So kalau untuk proses keluar pula, bila RI sensor 2 detect, slot akan bertambah di LCD. and server pun akan buka untuk buka pagar, dan sensor satu tak akan detect apa-apa. Dan bila habis slot ke-4 slot dia penuh, server motor tak akan buka pagar bila ada kereta lalu dekat IR sensor 1. Selagi mana slot kata kosong, full entry, full slot, dia tak akan terbuka.
Hello everyone, so my name is Nasir Halatis and my part is focusing on testing and findings of our smart car parking occupancy system. The testing was conducted to ensure that both the software and hardware components function correctly according to the project objective. We performed the testing in a controlled environment by simulating real parking scenarios such as vehicle entry, vehicle exit, and full parking conditions. Each component was tested individually before integrating the complete system. Next, for hardware testing, we test all physical components used in the system. This includes the infrared sensors, servo motor, LCD, Arduino Mercurio, breadboard, and wiring connections. Each component was tested individually before being integrated as a complete system to ensure proper functionality and stable operation. The infrared sensors were tested by placing an object in front of the sensors to run their ability to accurately detect vehicle movement at the entrance and exit point. The servo motor was tested to confirm that it could open and close the parking gate smoothly in response to sensor input, while the LCD was tested to ensure that it could clearly display system information such as the available parking slots and warning message. The Arduino Uno was tested as the main controller to ensure it could process sensors input and control the system outputs correctly. So in addition, the breadboard and wiring connections were tested to ensure secure and stable electrical connections between all components. No misconnections or power interruptions were observed during testing. Overall, the hardware testing results show that all components operated correctly without any malfunction when tested individually and during full system integration. Next, for hardware testing, we test all physical components used in the system. This includes the infrared sensors, servo motor, LCD, Arduino Mercurio, breadboard, and wiring connections. Each component was tested individually before being integrated as a complete system to ensure proper functionality and stable operation. The infrared sensors were tested by placing an object in front of the sensors to run their ability to accurately detect vehicle movement at the entrance and exit point. The servo motor was tested to confirm that it could open and close the parking gate smoothly in response to sensor input, while the LCD was tested to ensure that it could clearly display system information such as the available parking slots and warning message. The Arduino Uno was tested as the main controller to ensure it could process sensors input and control the system outputs correctly. So in addition, the breadboard and wiring connections were tested to ensure secure and stable electrical connections between all components. No misconnections or power interruptions were observed during testing. Overall, the hardware testing results show that all components operated correctly without any malfunction when tested individually and during full system integration. Based on the testing conducted, our smart car parking occupancy system successfully meets its project objectives. The infrared sensors function as the main input devices by detecting vehicle movement and sending signals to the Arduino Uno. Actually, the IR sensors only light up one light, but if there is an object in front of the sensors, two lights will light up, indicating that the IR sensor is working and can detect the object. So, when a vehicle enters the parking area, the servo motor opens the gate and the available parking slot count decreases. The parking gate will close again after the car passes through it. The updated information is displayed on the LCD in real time. When the parking area reaches full capacity, the system prevents additional entry by keeping the gate closed and displaying a warning message. This output is justified as it helps manage parking capacity efficiently and prevents overcrowding. Overall, the testing results demonstrate that the integration of software and hardware components works effectively, making the system reliable for real-world parking management applications. That's all from me.
So for the last chapter, this section is start with issue-based, project limitation, implementation, and the overall conclusion of the project. Firstly, what issues during project implementation? Several challenges were encountered during the development of the smart car parking occupancy system. This includes inconsistent IR sensor readings, unstable servomotor movement, and unsuccessful integration of the ESP8266 module for IoT connectivity. This issue mainly affected system stability and real-time data transmission. Next, for the project limitation, this system was developed as a small-scale prototype and was not tested in a real parking environment. The system operates locally without internet connectivity and relies on IR sensors that are sensitive to environmental factors such as light and pollution. Moving on to the recommendation. Future improvement can be made by using more accurate sensors such as ultrasonic sensors or camera-based detection. IoT integration can also be added to enable cloud data storage, remote monitoring, and mobile application features. Lastly, for the conclusion, the smart car parking occupancy system was successfully developed using Arduino Uno to automatically detect and display parking slot availability. Despite the challenges and limitations, the project achieved its objective and has strong potential for future real-world implementation. Okay, now let's look at the demonstration for our group. I kindly remind you to watch the video until the end. Thank you.
korang buka LCD dengan buka servo, dia kira boleh upload and benda ni aktif. Cumanya macam ni. Okay, memang dia boleh ni. Cumanya tak boleh ni lah. Tak boleh pakai servo dengan LCD. Sensor je yang boleh function.